the maintenance activity. And moreover, we may not need a full length of say 60 kilometers in case we want to carry out the maintenance activity in 1 kilometer of the OHG section. So we divide the entire OHG into different segments, and we make different smaller circuits so that as per the requirement, one of the circuit can be isolated for maintenance. The first one is sector, and there are three different nomenclature that I'll be using. Sector, that is the biggest section, then subsector, and the elementary section. So before we go further, I will try to explain what is a sector, subsector, and elementary section. The first one is the sector. It is the distance between feeding point to SP. SP is the location where the power supply from one TSS it gets terminated. SP is also the location where we have the neutral section, and normally the distance between FP to SP is 30 kilometer as per design. So the entire distance from one FP to SP, it is known as sector, and it can be energized by auto closing of a circuit breaker at the substation, and the energization of circuit breaker, it can be done remotely by using the SCADA by the controller who is in the control office. The second definition for sectioning is related to subsector. It is the smallest section of OHG which can be isolated remotely by opening interrupter, and it is required to ensure rapid isolation of fault on the OHG and to facilitate maintenance work. Normally, the distance is around 10 kilometer, and it is the distance between FP to SSP or SSP to SSP or SP to SSP. Like if we have one FP and SP is located at a distance of 30 kilometer, then we will have two SSP in between. The distance between two electrical installation which can be isolated remotely is known as subsector, and normally the distance is around 10 kilometers. The other one is the elementary section. It is the smallest section which can be isolated using manual operations. So that is the definition of elementary section. It can be done only using the manual operation. It cannot be isolated remotely. Now in this diagram, let us see the concepts which I explained today in the first two slides, and what I explained regarding SP and SSP in the previous session. Here, if you see carefully, we have power supply arrangement which is coming to traction substation, and after stepping it down using the transformer to desired value, that is 25 kV, we extend the power supply to feeding point. Now at the feeding point, it's a full structure and other equipments. We have 4 feeder wire. Each feeder wire is controlled using one circuit breaker, and each feeder wire is responsible to extend the power supply from feeding point to one side of the FP in either in up direction or in down direction. So if we are standing at FP, we have 4 circuits, 2 for upline and 2 for downline. That is one each in either side of FP. Any one of these circuit can be isolated by operating the circuit breaker. So it's possible for me to isolate power supply in upline, and at the same time power supply can continue in the downline also. Now in between we have the terminating location of this TSS is SP. At SP we have bridging interrupter which bridges the power supply from one TSS to another TSS in case there is any requirement on account of maintenance or on account of some problem with the distribution company network. Then we also have bridging paralleling interrupter. The function of the paralleling interrupter is to parallel the OT circuit of upline and downline. When we parallel the circuit, the overall resistance it gets reduced to half, and the I square R losses are reduced, and at the same time the voltage regulation is better. When I say voltage regulation is better, it means I get better voltage at the last point of the feeding tube. So we have two bridging interrupters and we have two paralleling interrupters which are provided at the SP, at the location of SP. Then the distance between feeding point to SP, it is known as sector, and the distance between FP to SSP or SSP to SP, it is known as subsector. In this diagram, I have shown only one SSP, but normally we have two SSPs in between FP, feeding point, and SP. Similar to the SP, we also have a sectioning interrupter, which is nothing like an emitter in a loose sense, which is aligned and which allows the current to flow from one side to another side. It always remains in closed condition because we want to extend the power supply from feeding point to SP. We also have paralleling arrangement using paralleling interrupters. It remains in closed condition, and we increase the number of parallel circuits in the entire OHE system. As we keep on increasing the parallel circuits, the resistance also gets reduced and the voltage regulation it also improves further. Now let us, in the next slide, let us see the functions. It's a small animation, and then here I have tried to explain whatever that I said in the session. At the TSS, when the circuit breakers get closed, the power supply it get extended to both upline and the downline. Here I have shown only one circuit breaker. Actually, we have two independent circuit breakers, one each for downline, one each for upline. This is the normal arrangement of traction substation, and this is the healthy circuit where the power supply is available to up to SP. The rectangle which are marked, which are shown in the black color, it means they are closed as of now. They are closed. That is why the electricity is able to go through these interrupters. Suppose we want to take a power block between SSP and SP. It means I want to carry out any maintenance in a 10-kilometer section. Then we have to discontinue the power which is available between SSP and SP. So how do we do it? We achieve it by opening two interrupters. The first one is the continuity for the sake of continuity, and the other one is for which we have used for the paralleling. The both OHE, that is up OHE and the down OHE. So the moment we open it, the power supply is not available now between SSP and SP, and the maintenance activity can be carried out. So this particular diagram or this particular arrangement, it is getting repeated in all the divisions in one after another. So we have large number of TSS located at different locations to feed the OHE. The entire section, it is known as sector, the yellow one, and the other one, it is the subsector. This is the overall diagram where I have mentioned some of the components and the equipments which are there in the overall supply arrangement. You don't have to remember this diagram. I'm not going to ask this diagram in the examination. It is only to inform you that there are a large number of components which are there in the TSS and PSI installation, and we are not discussing those install systems here in this particular session. Now let us talk about the overhead equipment. That is the second responsibility of TRD organization. The purpose is, there are two purposes. The first one is to maintain contact wire at appropriate level to ensure smooth current collection through the pantograph. And the second purpose is that the entire OHE arrangement should be as reliable as possible. So these are the two functions which the maintenance organization perform, the people who are involved for the maintenance of OHE. This is the basic and the first structure which is prominently visible to all of us. It is known as cantilever assembly. The cantilever assembly, it is entire cantilever assembly, it is mounted on the mast. So we have OHG mast. Then there's different tubes which are part of the cantilever assembly, and there they are stay tube. We have the catenary, which is on top of the contact wire. We have the contact wire, then bracket tubes, resistor tube, and the steady arm. So these tubes and arms, their basic function is to keep the contact wire and catenary wire at the desired location and at the desired height. So there are different adjustments which can be carried out. So that is the function which is being performed using these four tubes and the arms. We have two insulators which isolate the 25 kV OHG from the OHG mast. There is a question which Suresh has asked: how is interrupter different in functioning with respect to circuit breaker in the context of sectioning and paralleling post? There is a difference in the way we operate circuit breaker and interrupter. The circuit, this for in order to know the difference, you will have to refer the my notes that I'll be going to share you after this session before your lunch gets over. The other one is that we use circuit wherever we need circuit breaker. We use circuit breaker where we want any remote control operation, and where we want that the protection device it should operate under fault condition. And wherever we don't want that kind of an arrangement, we use interrupter. Interrupter is much simpler in installation, maintenance, and cost. So that is why we do not install circuit breaker at a location where we can manage the work with the interrupter. That is why the interrupter is being used for the sectioning and paralleling post. The other question which Shabad has asked is the purpose of catenary. The current it flows through both contact wire and the catenary wire. Basically, the arrangement is made in such a manner that a part of current it goes through catenary and the part of the current it goes flows through the contact wire. And in case we don't have the catenary and we only have the contact wire, the size of the contact wire it will become bulky, and the composition is also different. The contact wire is pure 99% pure copper material that I will explain in the subsequent slide. The basic purpose is to save, to reduce the size of the contact wire, and to because copper is costly and the cost of the contact wire is much more than the catenary wire. So we have the catenary and contact wire for sharing the current between both of them. The vertical arrangement that you see in between catenary and contact wire, that is the dropper. Dropper also has a role to play that I'll explain later. This is how the OHA system it looks like when we see it from the side. This is this is the photograph of a contact wire. It's a grooved hard drawn copper. Cross section area, the diameter, this is the normal tension. As the 25 kV OHE system is regulated OHE, it means when I say regulated OHE, means we keep it under tension from both the side. And when we keep the contact wire under tension from both the side, it remains in horizontal condition. And the transfer of energy from contact wire to pantograph is smoother because the contact does not break during the run. The braking load capacity is 3,900 kilogram. We never reach this situation online. The braking load is always tested before accepting the material at manufacturer's premises. So this is one of the parameters to before we pass the copper wire or the contact wire to be used in TRD system. The condemning dia or condemned dia is 8.25 meter. As the underside of the contact wire, it is in constant touch with the pantograph. There is also wear and tear in contact wire. And when the contact dia of the contact wire it reaches 8.25 mm, then we have to replace the contact wire. how the catenary wire looks like. There are 19 strands of cadmium copper, and this is the overall dimension, overall sectional size, the normal tension, and the breaking load. The condemned dia means that's a question from Akash. That is the point when we have to replace the entire OHE. When we purchase the contact wire, we receive the contact wire in the form of drums, and one drum consists of 1.5 kilometer of contact wire. So they are whenever we want to replace the contact wire, we have to replace one length of contact wire, which is 1.5 kilometer, and it is also known as tension length. That is the nomenclature that we use. When we use both contact wire and catenary wire, somebody asked what is the purpose of catenary wire. So here it is there. We convert the entire surface area into equivalent copper section, and the equivalent copper section is 157 per mm square, and the current capacity of the entire system is 4 ampere per mm square. So we can allow the current of 600 ampere to flow in single OHE. So that is the upper limit in case we want to know as to how many trains can be operated on upline. Then the entire loads, all the loads which are using electric traction, then the entire load should not be more than 600 amperes. Earlier, that was never a restriction because the number of trains were less and the speed of the train was also less. Now, over a period of time, we have increased the speed and we have also increased the load in the trailing load and the trailing stock. Now there is a requirement that we increase this permissible limit from 600 ampere to much higher. That is why Railway Board has recently decided to go for the next technology, that is 2 into 25 kV technology. But till now, it will take many years to get commissioned in most part of the country. To begin with, we have identified from Delhi to Howrah section where this work will be executed for the first time since 1997, when we had only one section in Indian Railway. The function of the dropper is this is the function of the dropper. It keeps the contact wire at the same height above rail level by supporting it from catenary at regular interval with the help of the droppers. This is how a dropper looks like. Just have a look at it. Don't remember the diagram. Not going to be asked. There are different components within the dropper. Size is also standardized, and there is an eye which is in between the dropper. It's not a continuous vertical copper material which connects both catenary wire and the contact wire. We have provided an eye to take care of the vibrations which are there when the pantograph moves under the contact wire. The pantograph, it has a pressure of 7 to 8 kg using the pantograph servo motor, and that pressure, it allows the contact wire to give an upward thrust on the contact wire. Because there is an upward thrust from the pantograph, the contact between contact wire and the pantograph, it is very good, and the current collection is also good. But because the pantograph is moving it in upward direction, that thrust or the pressure, it has to be absorbed by somebody, and the function is performed by the dropper. So it is like a shock absorber in our four-wheelers. When the pantograph moves, the shocks are being absorbed by the pantograph, by the dropper, without disturbing the overall geometry of the entire coach. This is the OHE vertical mast, which is there, which is used to mount the cantilever assembly. It can be rolled section or a fabricated structure. And the other important criteria as to where are we going to install the OHE is regarding the isolation of upline and downline. In the mid section between two stations, in a double line section, the masts are independently used for downline and upline, as so that we can keep both the circuits independently, both electrically independent as well as mechanically independent. Now I'll explain why do we need them to keep independent. we have to keep them electrically independent so that in case we want to take maintenance block, we can take maintenance block only on one line. If I want to carry out function or work on downline, the traffic should be allowed to operate on the upline. It is possible only if the foundation and the mast and the OHG they are independent. If I have both the cantilever assemblies for both up and down line on one structure, it will not be possible for the staff to climb on that structure to carry out the maintenance activity. We want to keep them independent mechanically also, because in case there is a derailment near the mast, then the mast may get uprooted, it may get damaged. If the mast is uprooted or damaged, then the electrical power supply to both downline and upline it will get disturbed, and there will be, and the it will not be possible to provide any rescue operations using electrical traction. These are the two reasons why we keep them independent. This is how they look like. Mast is the fabricated mast on the left hand side and the casted mast on the right hand side. We also number a mast uniquely, that is can be seen here. The unique number which is given to the mast on the right hand side is 386/13. It means this mast is situated in between kilometer 386 and 387. It is the 13th mast when we start numbering from 1, and the overall distance of this mast is 386 plus kilometer from the headquarter. So these are different significances when we identify a mast uniquely. The mast numbers are also being used by the officers and the staff of all the other departments whenever they want to report any unusual which is either in their own department or which has occurred in somebody else's department. Immediately it is referred that an derailment has taken place between mast number 386/13 to mast number 386/15, or there is some foreign material which is available on track which may become a cause of derailment between mast number so and so, or there is a crack which has developed between mast number 386/13 to different mast. Now, earlier we did not have the provision of GPS location. Now, each and every mast has its own GPS location. The moment such unusual report comes from the site, all of us can see it, the actual location of the unusual, and the rescue operation or the maintenance team, they can be mobilized from the nearest possible location. So these mast numbers, these number plates, they are unique number plates, and they are being updated or painted at regular interval. There are certain locations where it is not possible to have two independent masks for to cater to OHE of two lines. At all such locations, we used another arrangement which is known as two track cantilever or TTC mast, and it is being used where the track centers are restricted. We need a minimum distance from the center of the track before we decide to commission or erect a mast at that location. If the distance is not adequate and if it is infringing schedule of dimension, then we have to use TTC in place of using two independent masts at that location. This is how it looks like. It has one boom and one upright. And here in this photograph, you can see that we are using it to cater the power supply to OHE. Normally, TTCs, they are used in our yard area where the tracks are converging to take care of the platform, or they are moving out from the station yard to midsection. In case there is a requirement to feed OHE for more than two tracks and the track centers are further restricted, which normally happens in the yard, we use portals, and the portals has two upright and one boom. That is the structure. It is brought in knockdown condition at site and fabricated and welded before erecting it at the position. Here in this particular photograph, we have mounted OHE for 4 track on the portal. On the left upright, there is one OHE. On the boom, which is right in the middle of the screen, there is another OHE. And then we have two uprights or two cantilever assembly which are mounted on the right side of the right upright. So there are different number of OHE arrangements which are provided at one portal. If I'm using for 4-track, it is known as N-type portal. And if I'm using for 8 tracks, then it is known as R-type portals. This is the arrangement of OHE on portal. Just remember it, not don't remember it, just have a look at it. You don't have to remember this diagram. Here in this particular arrangement, it's a portal arrangement to take care of 4 tracks. 2 OHE are on the upright and 2 OHEs are on the boom. The distance between 2 mast or 2 portal, it is known as a span, and the minimum distance which is there is 27 meter and maximum is 72 meters. The distance depends on various parameters. The terrain, wind pressure and alignment, that is the curvature, they are the 3 basic parameters before we decide the distance or spacing between 2 adjoining masts. We have divided the entire Indian Railway into 3 different wind zones. And if the OHE arrangement is to be carried out at the highest wind zone, then we provide the smaller distances between the mast. That means in a section which is in high wind zone, the span will be somewhere around 27 meter. And it is if the wind pressure is small, we can go for span which is as close to 72 meters. Again, there are standard spans which are used at the interval of 4.5 meter. It is decided to have minimum inventory, and that is why we have standardized the interval so that we don't have to procure the inventory for different intervals. The droppers, they come in set. In case I have a span which is 27 meter, I need 4 or 5 droppers. The droppers are numbered, and during the construction, we erect them as per the location 1, 2, 3, 4, and 5. And when we mount contact wire and catenary wire on top of them, the entire catenary and contact wire, it takes the shapes automatically. So we don't have to do any adjustment into it. So these are the reasons. Just to have minimum number of inventories, we have standardized it, and these are some of they are also taken care of at the time of the design of new OHE. This is how the OHEs are masked. They are indicated. Normally we have 15 to 18 masts in one OHE. In double line section, the masts which are used for upline, they are odd in number, or they are odd numbered. That means 75 by 1 and 75 by 3. And for the down track, they are even numbered, 75 by 2, 75 by 4. So they are constructed or installed in a zigzag manner. 71 by 5 will be the first one when we move in a particular direction. Then we will come across 75 by 2. And when we go further, we'll come across 75 by 3. So the direction or the location, it will keep on changing from left to right and then from right to left. We have neutral section. We have already spoken about it. What is the function of neutral section? It separates the area which is being fed by 2 adjoining or adjacent traction substations. The conventional overlap, there are 2 types of neutral section, which I would like to explain. In the conventional system, we have 41 meter long overlap. That means when we have, as I said, when we get the contact wire, we get in the form of a drum, and each contact wire is 1.5 kilometer long. When after every 1.5 kilometer, I have to provide next tension length, and there we need an arrangement so that the pantograph, it can move from one jurisdiction to another jurisdiction without breaking the mechanical continuity. And we also have to ensure continuity of electrical current from one tension length to another tension length. Some of those functions they are provided by using the overlap, or wherever we need only mechanical continuity and not the electrical continuity, then we provide the short type neutral sections. So these are the two different arrangements that is again used as part of the overall OHE design system. The This is how the conventional type neutral section it looks like. And here you can see that there is one wire which is getting terminated, and there's another wire which is getting enhanced. And it is being whenever we design it using 5 consecutive spans of OHE, and the only restriction is that the center span it should be strictly 49.5 meter. And when we have 49.5 meter, then the neutral zone it is available at the distance of the 41 meters. So this is the requirement whenever we want to go for conventional type neutral section. Here is a question which has come from Suesh. Why do we provide single phase supply instead of 3 phase through TSS? The design that we use is single phase power supply, and since I am having only one set of contact wire and the catenary wire, they work as a single set. So I can only transfer single phase power to the pantograph. In case I want to transfer 3 phase power, then I need 3 such arrangements, and I also need 3 independent pantograph to take care of individual phase. Life is going to be very complicated. And till recently, till 2016, we were having the DC traction motors which were operating on DC. So there was no requirement for 3 phase power supply. The requirement of 3 phase power supply is now coming into picture because we have 3 phase locomotive. That is the reason we are not doing. And how the neutral section it easily takes care of the phase difference, because at the neutral section there is no power supply which is getting extended from one side to another side. In case we want, it's a in a neutral section, it's a electrically dead zone. So the power supply from two different zones they are isolated. Only if in case we want to extend the power supply at neutral zone, then we have to switch off the power supply of other phase first. Once we switch off the power supply, I can extend the power supply of other phase to the different area. There are some advantages of conventional type neutral section. It's a maintenance free, and the most the two disadvantages which are very important to know. First one, there is a possibility of a locomotive getting stuck in the dead zone. We have a dead zone of 41 meters, and the distance between two pantographs is less than 41 meters. So in case there is an alarm chain pulling and it matches with the reduction of the speed in such a manner that the pantograph they are in the dead zone, then it is not possible for the loco pilot to use any one of them to clear the section. And we have to send either a diesel loco or an electric loco to either pull the train or push the train to any one of these stations which are on either side of the train. The other maybe because of the bad driving skill of loco pilot. In case he is controlling the speed, or if he is not careful and he does not maintain adequate speed of the train, then there is a possibility that the loco may get stuck in the neutral section. This is considered as a crime, and a very severe penalty is normally imposed on the loco pilot if it is because of his bad driving skills. In alarm chain pulling, he cannot control, but he is supposed to control the driving skills. He should be confident about it. And because if there is if such kind of a situation arises online, it creates a lot of chaos for the entire traffic. Many trains gets delayed which are following this particular train. So these are the two disadvantages that we had for the neutral section. So now we have another concept is the section insulator. It is provided in the contact wire for electrical isolation of two sections from each other while providing a continuity for the pantograph. So where is the role of the section insulator? It is provided at emergency crossovers. We have different locations of emergency crossover where traffic from upline to downline or downline to upline can be moved. Now, when the train is moving from upline to downline, the pantograph is raised, and we need power from to be taken by the pantograph. But at the same time, we want to keep the OHE of upline and downline isolated from each other, so that during the maintenance we can take the shutdown. Therefore, we use section insulator at the crossover to isolate the OHE of upline from the downline. And it is also used at turnouts and other loop lines so that we can isolate the elementary section for maintenance purposes. This is how the section insulator assembly it looks like. The it is charged from either side, but there is a small portion where there is no electrical current. This is the entire arrangement, which is now filled with the box, is the insulator assembly. Here, if you see it carefully, there are two horns. It is not straight. At the end, they are bent upward. These are the horns, and there is a function for these horns. They are always provided in the trailing direction of the movement of the train. So when we have this kind of an arrangement in a section, then the direction of movement of train will be from left side of the screen to the right hand side of the screen. This is so that the pantograph does not get entangled into these rudders. So these are known as rudders, and suppose there is some mechanical unbalance in the overall fixing of the section insulator assembly, it may come down, and during the run, the pantograph may come and get entangled into the rudder of the sections insulator assembly. So we always provide it into the trailing direction. In case I want to use section insulator in the neutral section, so we use two section insulators, one after another, and there is no current in between the 5-meter distance which is there between two neutral sections. This is how it looks like, and there is no current in between. This is the reason why we do not use the section insulators for the main line. We avoid use of section insulators in the main line because then the speed gets restricted to 100 kmph. This is the short type neutral section. It's a dead zone of 5-meter length where no electricity is available for the traffic. These are the reasons why we do not use neutral sections on main line, because they are heavy in weight. They add to the dead weight of the entire system. There is a restriction of speed, and frequent maintenance is required because it is again an assembly by itself with a lot of components which are there into it. This is again an important issue. We have different neutral sections at different locations. And the loco pilot, he has to be very careful while negotiating the neutral section to avoid some of the issues which we have discussed earlier. And the loco pilot, he is supposed to know the location of the neutral sections. It is part of his training that he should know the section perfectly. He should remember the section very clearly. Still, we provide 4 warning boards to the loco pilot to warn him that he is about to negotiate a neutral section. So it is there are 3 warning boards which are provided before the neutral section, and there is 1 warning board which is provided after the neutral section. So these are the locations. The first 2 are only for the warning to indicate him that he is about to negotiate a neutral section. The other warning boards are regarding the operation of the circuit breaker or the DJ. At one of the warning board, he is supposed to open it, and at the other location, he is supposed to close it again. So here in this diagram, you can see it. So the The total number of warning boards which a loco pilot is required to negotiate a neutral section are four in number. Three are prior to the neutral section and one is after the neutral section. So in all, it's a combination of four warning boards. And this is the shape and the size of the warning boards which are provided for him for his guidance. The first two indicate the location of the neutral section which he is approaching, and the third one and the fourth one is regarding the operation of the circuit breaker. We have two type of OHE. We have discussed a little bit about of it. We'll go over quickly. The first one is the unregulated OHE. The DC sub OHE was primarily unregulated OHE, and AC OHE is primarily a regulated OHE. In the unregulated OHE, there are continuous expansion and contraction in the contact wire due to variation in temperature, and we have no mechanism to control the expansion and the contraction. So if there is an expansion, the sag will get increased, and if there is more sag in the OHE, the interaction between pantograph and the OHE will get affected. And if the sag is beyond permissible limit, there is a possibility that the pantograph it may hit the OHE, and in that process, both contact wire and the catenary wire may get both contact wire and the pantograph it may get damaged. So this is the simple system because we don't have to provide a regulating mechanism. It is again a set of components which have to be provided and maintained. So this is the simplest design. And when we moved in onto the electric system way back in 19th century, we started with the unregulated system. It is not suitable for speed more than 100 kmph. In those days, 100 kmph was not even thought of. So this system continued for a long time. In the regulated OHE, we have some mechanism which can maintain the height of the contact wire as per requirement under all temperature conditions. The arrangement that we have, it is known as anti-creep arrangement or auto tensioning device, and they are provided at both end of the OHE termination. And with the provision of auto tensioning device, we can maintain the tension in OHE of both contact wire and the catenary wire. This is the diagram which I have. This is a photograph or the diagram which I am using to explain the concept. There are three pulleys, and we have a counterweight. They work together. They work in tandem to make sure that the adequate tension is available in contact wire and catenary wire, which is 1000 kg. So they operate as per the requirement, and the tension is taken care of during the entire year. So these are some of the concepts. The TRD is one wing of electrical department which is new to all the probationers. Even when I heard TRD or came to know about TRD when I joined as a probationer, even I found it little bit difficult to apprehend or understand for the first time, because this is not part of our curriculum in our engineering colleges, and we don't come across all these components and all these terminologies earlier. So I can understand that some of the concepts which I am explaining right now may be difficult for you to appreciate immediately. You may require to go through these slides once again before the exam. So please go through them once again so that at least you know some of the terms which may be important for the exam purpose. Don't remember the diagrams and the photographs. I'm not going to ask you to draw any diagram, say for the overall TRD system or for the neutral section or for the overlap kind of an arrangement, or for that matter, I will not ask you to draw this regulating arrangement. Although I can ask because it's very simple to draw without giving the details. But I'm not going to ask these kind of questions because it will unnecessarily involve mugging up the material. And my focus is that I should be able to make you understand the concept rather than remembering these diagrams. So don't worry about the photographs and the diagrams which I'm showing you in TRD presentations. This is how it looks like. There are three pulleys which are on top of the mast, and then we have the counterweight which takes care of the overall arrangement. There are some other important parameters which are important for proper working. They are height, implantation, encumbrance, and stagger. These are the four technical words which are being used in OHE maintenance. I will explain them in the next slide, and I will also explain how they are measured. The normal height of the contact wire is 5.60 meter. In the main line section, in the section between two stations, beyond the yard limits, the height of the OHE is 5.6. Minimum, it can be 4.80 meter. If we have an ROB where it is not possible to have a height of the OHE as 5.6 meter because of the space constraint that we have under the ROB, we can have OHE height as 4.80 meter. Maximum, it can be 5.80 meter, which is permissible in the yard. And at level crossing, this is the minimum height which has to be kept to ensure safety of the people who are using the level crossing gate. It cannot go below this. And this is how we measure the height of the contact wire. We take the center line of the track and we measure the vertical height to the bottommost contact point of the contact wire. And the value that we get is the height of the OHG. We also provide a height gauge at the LC gate to make sure that electrical safe distance is available between the topmost part of the moving vehicle and the lowest part of the live OH. So height gauge, they are very important and they have to be maintained at appropriate height during the service. The implantation is the horizontal distance which is available from the nearest face of the traction mast to the center line of the track. These are the normal implantations. Earlier it was 2.5 and 2.35. Now it has been increased to 2.8 and 2.5. The encumbrance is the axial distance between the vertical plane between the contact and the secondary wire. Here I'll show how we measure both implantation and encumbrance. So again, the center line of the track, it plays an important role, and the distance from the center line to the nearest location of the mast, it is implantation. These are the different values which we have. The encumbrance is another value which is important, and this is the axial distance between the contact wire and the catenary wire. The implantation is also be required to be maintained to ensure safety of the passengers who are leaning outside the coach. We have many number of people who prefer to travel on the door, even if there is a vacant seat which is available in the coach. And when they lean out of the coach to enjoy whatever they want to enjoy, they also have a carry bag or rucksack which is already there on their shoulder. So when they lean out, they move out of the SOD, and they have a backpack with them. So there is a possibility that they may hit by the mast which is there, which is about to come when the train is moving in forward direction. There are cases, especially in metro cities and in some big cities, where we have found the cases where despite maintaining a distance of 2.5 meter from the center line of the track, there is a casualty because somebody was leaning out and he was hit by the mast. It may happen with the railway officials. This incidents may happen with the railway employee also. Last year, we had a very unfortunate case when one of the young electrical engineer, he was posted as AEE operation, he lost his life while footplating the locomotive because he leaned outside, and when he leaned outside, he did not take care that a mast is about to come, and he lost his life. So it was very unfortunate that an officer who was a young officer, he lost his life. We have some cases also earlier when the loco pilot or the loco co-pilot they also were hit by the mast. And especially the people who are traveling in the passenger trains with their, something which is there on their back or on their shoulder. We have seen some cases, and whenever a person gets hit by the mast, his chances of survival are very less. So we, all of us, have to be very careful that the implantation is not only to be maintained, it has to be ensured throughout the service. Whenever we measure the implantation, we write the value of the implantation at the base of the mast. Suppose I measure it that the implantation is 2.7 meter. I write it with the, with some marker or with the some pin. During the maintenance by the engineering department, they slew the track either towards the mast or away from the mast. When they slew the track, the implantation should not go below the permissible limit. If it goes below the permissible limit, then the track is either to be slewed back to the original position, and if it is not possible, the mast has to be moved away from the track. So there is an interaction between the civil engineering department and the TRD department to make sure that the implementation is kept at the required value. The other concept is the stagger. This concept is required to maintain, to ensure that the rubbing of the pento strip is uniform. In case I don't provide stagger, if the contact point between the contact wire and the catenary wire is a single point during the journey, a groove will form in the pentopan strips. Sorry. A groove will form in the pentopan strips, and at a later time in the journey itself, the contact wire may get entangled with the groove, and it may damage the pantograph and the contact wire, both of them. So, in order to have a uniform wear, we keep on moving the point of contact between the contact wire and OHE, and it is a part of the design. And how do we ensure the uniform rubbing? We stagger the location of the point of contact. It is plus minus 200 mm on the straight line on either side of the center line, and it is plus minus 300 mm on the curve. Here I will explain you with the small animation. We have a pantograph and a strip which is on the left side of the screen. The dotted line is the center line, and the zigzag line is the point of contact of the contact wire with the pantograph strip. This is how the OHE will look like if we see it from the top. So when the pantograph is moving, the point of contact of the pantograph with the OHE, it will also change during the journey. So if the way it is moving, the point of contact it is moving, it is not the same. It gets changed after every interval, and the stagger it is maintained plus 200 mm or plus minus 300 mm during the entire length of OHE. So this is how we ensure uniform wear and tear. And once the logo goes to the trip shed, we see the thickness of the pantograph and strips. And if required, we replace it immediately. I don't know whether it is working or not. So the overall OHE system we have already seen. This is the span. This is how we define the span between two masts. The overlap we have already seen. It is required to provide the mechanical continuity and the smooth passage. So at the location of overlap, we have two sets of traction conductor which run parallel for a short distance, and so that we can transfer the contact of OHE from one span to another span. This is the concept of overlap. Not very good animation, but it is already there. Here, the pantograph it is losing the contact from one portion, one tension length, and it is making the contact from the other tension length. So one OHE, after traveling for a certain distance, we terminated it on one of the mast, which is indicated with the blue color, and the other OHE it takes off from the mast, which is marked with the black color, and slowly it comes in the center of the track. And at one location, where there is one location where pantograph leaves the contacts from the left hand side OHE and it makes the contact with the OHE which is there in the right side of the entire system. This is how it looks like. We have the one tension length which is marked with the blue. It is going to make the transition using 5 masts, and there is another OHE which is marked with red color. It is also making a transition from the leftmost portion, and because they are both the tension length, they are fed from the same OHE. So we also need a continuity of the current. And that continuity of the current, it is provided using the C jumper. We have a jumper arrangement or a solid copper flexible conductor which connects both the OHE. And when we connect both the OHE, there is a continuity for the electrical current to flow. So this is how the transition it takes place, and it's very smooth transition. Nobody comes to know that we have moved from one tension length to another tension length. The maintenance of parameters in OHE are it's a very critical activity because the most of the parameters they are defined in the form of in the form of centimeter is something which is which is a luxury. We define the tolerances, very fine tolerances, and the amount of work which is to be carried out by the OT maintenance staff is it's a quite big, quite huge amount of work which they have to perform. And now we have some devices which can help the staff to record different parameters automatically, and we run that device in the using either or the using the motor trolley or using one of the cabs of the locomotives. Different parameters get recorded, and then we can, based on the value of the parameters, we can decide the maintenance activity. So the technology, then the digital technology, it is also helping PRD people in the maintenance. Now, these are the two important uh, clearances which are relevant to all of us. One is the clearances, which is the for the stationary object or the stationary building, which is supposed to be taken care of when we are designing a building by the civil engineers. That no fixed structure should be less than this distance. The other one is the working clearance, which is important for all of you. You will be part of one or some or other inquiry related to TRD department or other department, where you are supposed to go on top of the loco to make your observations. Please make sure that the loco is dead before you climb the roof of the locomotive, because the minimum distance which you have to maintain from live OHE is 2 meters. Again, we have had casualties in past in the workshops in the loco shed when the staff it climbed the loco roof and came in contact with the OHE. So this is another important clearance which is supposed to be taken care of for your own safety, for my safety, and for the safety of our staff. These are the fixed. These are different maintenance schedules. Now I'm not going into detail. They are similar to what we do in the loco maintenance. They are all prescribed. They are all laid down by CAMTAC Gwalior, and we have to carry out the inspections accordingly. The parameters they are being measured during the different inspections. There is a difference between the blocks. That is again something which please note carefully. There are two types of blocks which are being asked by electrical TRD department. One is the traffic block, means there is a complete blockage for traffic. It means I cannot run the traffic using any type of traction. It may be diesel or it may be steam traction. So the entire traffic movement of the traffic is not permitted. That is the traffic block. The other type of block which we ask for from the traffic department is the power block. In that case, the electrical supply is switched off. It means electric traction cannot be used. But we can use the section using diesel traction. This type of block we take when we want to do the maintenance in the substation or SP or SSP. So this is the difference between traffic block and the difference between the power block. Please remember the difference between traffic block and power block. There are other things which is relevant to civil engineers and SNT officers and to electrical department, because this affects your proper working or your working on when you work in the field. there may be an electrical interference or because of the electric circuit which is there at 25 kV. We need a proper return path to avoid any interference with any of the safety devices installed in the on the track. So how do we ensure it? We ensure it by using the bonds. So bond is a connection across a joint, it may be glued joint, it may be insulated joint, or between the adjacent length of a rail or between mast and the rail to provide continuity for the return path, return current, or to provide continuity for the fault current. So that is the purpose of the bond. Without the bond, circuit will be incomplete and it may affect the safety of some of the equipment which are there on the track. We have a structure bond. We use a structure bond to earth the structures, that is mast, portals, or any other structure which is there in the section. Then we have rail bonds. It is primarily used for the return current. We have continuity bond and the cross bond. So these here is the diagram. This is the last slide for the TRD. We have here I have shown two rails of the same track. So the two horizontal lines, they represent only one track. In earlier slides, when I drew two lines, each line represented one track. Here it is two rails of one track, and there is a discontinuity in the track as you can see. So I need to make good this discontinuity. If there is a return current, then discontinuity is being maintained using the continuity bond. Now, once I have the continuity bond, the path is available to the glued joint. Now I have to somehow ensure that the return current is can pass. So we change the rail, we go to the other rail of the track, and then we have continuity bond, and the return path goes to the system. This is how the in the photograph here down below I have shown the cross bond, how the cross bond actually looks like. Then this is a mast, how we use the structure bond on in the situation. So that is all that I wanted to show you in TRD. I'll just take 1 minute that we have different types of foundations. I'm not going into the details of the foundations. They are named independently and as per the location, as per the wind speed, as per the characteristics of the soil, we decide whether we have to, which of these foundations are supposed to be used. And I will only show one slide where I have indicated uh, different types of the foundations. This is how they look like. We have different types of foundations, OHE foundations, and each type of foundations has its own geometry. The size of the OH it is decided. The work of OHE foundation, it is being executed by electrical department. The work of OHE foundation, it is not being carried out by the civil engineers. The, during the construction activity, it is a part of the entire OHE contract. And once the foundations are casted, the masts are erected, the maintenance of the foundation, it is also being done by the electrical department. So there is one location, small area where the electrical department is independent of civil department. So that is all that I wanted to share with you regarding GRD. It's a big presentation, and yes, it's a new concept. It will take some time before the concept of TRD it sinks into your mind. And some of the concepts may be new. Most of the terms which I have used are new. So please go through it once before the exam. Now give me 2 minutes so that I can move on to TRO. And today we'll try to cover TRO and safety and distributed traction that we will try to cover during the last presentation that we have on that we have tomorrow. I think tomorrow we have the last session with you, S5 and S6. Let us start with the TRO organization. I have already shared 4 PPT in the Google Drive, which I have created. And today, after your session, I will also share the TRD presentation in the Google Drive. You can have a look at the drive for the PPT. And tomorrow I'll upload all the other 2 PPTs. There will be three more PPTs. One is for TRO, one is for safety, and the other one is for the distributed traction. All these 3 PPTs are smaller in size, so you need not worry about that. You will get it. You will get sufficient time to go through them. The TRO, it has 2 functions. One is the loco management, and the other one is the crew management. In the loco management, there are only one function which is important, that they have to manage the locomotives which are available to the TRO organization efficiently, safely, and reliably. When I say that they have to manage efficiently, it means we have different types of locomotives in the section, in the division, and the requirement of a locomotive is also independent of the requirement of another trailing load. For the mail express train, I need mail express locomotive. For a goods locomotive, if it is heavy goods train, I need WAG 9 locomotive. And if it is the weight is less, I can still work the train with the inferior loco, that is WAG 5 locomotive. So the number of locomotives which are always available at the disposal or for TR organization, they are limited. So he has to plan it very carefully to make sure that there is no incidence where a train is stabled or a load is stabled for want of appropriate loco. Safety is important. Before allowing a locomotive to run in a train, the safety certificate, which is issued by either by LocoShed or issued by the trip shed, that should be available with the TRO organization. And reliability is important. That loco which has been provided, it should not fail online. Sometimes the TRO organization or the controller, he has some past experience of this particular locomotive and how it performed during the last 2 or 3 journeys. So all that data is available with him. He can use that data to decide whether to use this locomotive or not to use locomotive. So basically, TRO organization, as far as loco management is concerned, it works as an aggregator, the way we see Ola and Uber in the road transport. They don't own it. Frankly speaking, they don't own the asset. But at the same time, they are responsible to ensure that there is no passenger complaints. Same is true with the TRO organization. They practically don't own the locomotive because the ownership belongs to the TRS, but with the TRS, with the loco shed. But they are responsible to for the proper working of the electric locomotive. The other responsibility is regarding the crew. Now, for both diesel and electric traction, the crew reports to PRO organization. Again, there is a shortage in staff in the crew that we have to manage with the available crew that is there, taking care of their leave requirements and other related issues. The periodical medical examinations, it's prescribed in the manual, and no crew should run overdue for the periodical medical examination. As and when the crew becomes due for periodical examination, he is asked to report to the hospital, get him examined, and only when he gets the fit certificate, he is allowed to perform his duty. So periodical medical examination is again something which is very important. And training, we are changing the technology. We are moving from DC traction to 3-phase traction. We are now using more number of digital display kind of arrangement, which is there now in locomotive. And we have a lot of microprocessor based diagnostic systems. The crew should be able to not only read the messages which are getting displayed in the driver's cab, but he should also be able to take the appropriate action. Therefore, training is very important, and the training is being given in the classrooms. Training is also being given using the simulators, where we actually see his alertness, and we also judge him for his driving skills. After every test on the simulator, he is graded, and wherever there is a weak area, where he is again counseled or trained to improve the weak area. So training is something which is very important for the management of crew for TR organization. All the data which is there for the crew, it is being maintained in the system, and anybody can have a look at it. The TLC is the organization which coordinates with the different agencies. They coordinate with the loco pilots. They coordinate with the other departments of Indian Railway. They also coordinate for loco failure. A loco may belong to Vadodara division. It may fail in Chennai division. So he is for the TLC organization of Chennai division. He is the first one who is supposed to take care of the loco failure. In case there is any accident, maybe on account of electric loco or may not be on account of electric locomotive, but he is supposed to coordinate with other departments for the rescue operations, for evacuation of passengers, for clearing the sections, and to decide whether to send a diesel locomotive or the electric locomotive. So the TLC organization, he has a very important role to play when there is any unusual or accident on site. They work with the operating control. The trip shed is another important responsibility for the loco TR organization. We had discussed there are certain maintenance activities which have to be carried out by the uh, TR organization, by the electric loco sheds. We have IA schedule, IB schedule, IC schedule, AOH and IOH. These five activities are being carried out by the loco shed. Other than these two, there are two activities which are not being done by the loco shed. The first one is the trip shed. The trip shed activity, maintenance in the trip shed or the trip schedule that we call, it is not done in the loco shed, it is done in the trip shed. So that is the difference. And again, the POH activity, which is the periodical overhaul activity, it is also not being carried out by the loco shed. It is being done at the workshops. So these are the two activities which are done outside the locomotive or outside the locomotive workshops. The another general safety checks, they are being carried out after completion of each journey. Once a train completes the journey, the loco is detached and it comes to the trip shed, and the coaches are detached and they are taken to the coaching. There, the all safety related parameters they are being checked, and a safety certificate is issued to TRO organization, to the same organization, and the logo can be used for the next journey. We have the facility where pit lines where the staff can go under the locomotive. There are well lit pit lights, and he can examine all the components or the equipment which are mounted in the underside of the locomotive. And we also have a facility to isolate the OHE for the roof inspection. So this is the location where some of you may be required to go on top of the locomotive for carrying out some kind of a joint examination. The OHE here, it can be isolated from both sides, and it should be isolated from both sides. Proper earthing arrangement should be provided on both sides of the locomotive before anybody climbs on the locomotive. There are incidences when people got electrocuted because they did not follow the basic principle of isolating the OHE from both the sides. These are some of the duties or the functions which are carried out at the trip shed. There are different failures which are reported on account of failure of electric locomotive. There are two. It can be classified either as failure or as unusual. Failure means when the loco is completely dead and assisting loco was given. Unusual means when there was some problem in the electric locomotive and train lost the punctuality. So these are the unique numbers which have been assigned for the failures which are on account of the electric locomotive. Similar numbers are available for other wings of electrical department, and similar numbers, independent unique numbers are available for failures of other department. So at the end of the day, a list is being prepared for all the failures which have occurred on account of all the department. A computerized sheet is prepared and it is being circulated for everybody to take care of the unusuals and to initiate some remedial actions. So these are some of the unique numbers which are assigned to TR organization. We have a concept of loco link where the train loco is pre-decided as to how it is going to perform the entire journey before it is returned back to the homing check. So loco link is prepared. It picks up a train at Ahmedabad, goes to Mumbai after getting the trip inspection done, and after waiting for certain pre-decided hours, it takes another train, goes to a different destination. But after completing a pre-decided number of days, say 15 days or 35 days, as per the type of the locomotive, the loco is not then returned to the nominated loco shed. So this is how we nominate the loco link. They are optimized and reviewed as per availability of the locomotive. The other function which is there to for the management for the PR organization is the crew management. I will take only 5 more minutes before we close the session. In the crew management, it is the loco pilot and the assistant loco pilot management, which is supposed to be performed because we have limited number of loco pilot and the right person should be assigned to operate the right train. Then we have the crew links, similar to the links which we had for the loco. And there is a location which is known as crew lobby where the loco pilot he is supposed to sign on or sign off before performing his journey. So these are the three different areas or the locations which are responsible for crew management. Now, this is the loco pilot management, how the loco pilot management is being carried out, and what are the different functions when we talk about loco pilot management. First one is the booking of loco pilot as per roster, as per the requirement. Maintenance of complete data, biodata, it is now available on computer. TLCs of different divisions, they can see the biodata of the loco pilot. Ensuring timely availability as per the requirement. No load should stable remain in stable condition for want of crew. At the same time, crew should not remain idle at the lobby because the time starts the moment he logs into the system. And in case there is no train and if he is waiting for 2 hours before driving another train, then practically we have lost 2 hours for him, which was available to us, and we have to ensure his rest after 6 hours. So it is synchronized in such a manner that as and when we have the need, we call the loco crew to report on duty. Till such time, he can either remain in the running room, that period is counted as rest, or he can remain at his home if he belongs to that particular city, and that is again counted as a part of his rest. So timing, availability, and appropriate time for signing on and signing off, that is also important because his duty hours it is counted from the time he signs on in the system and the time he signs off in the system. The grant of leave, another important responsibility, planning of training, planning of promotional courses, that goes without saying, it is applicable to all the departments. So these are some of the coordination with the allies. I will briefly talk about the functions and the role of the allies. And that is all was there for the crew management. These are the crew links. That is how the crew links, they are being maintained in the entire system. I have also kept an alarm to indicate me that it is time to wind up so that I don't keep you waiting for the lunch. But still, I will take another minute or so before we close the session. The Similar to what we had in the local link, we also have the crew link, and the function and the modalities they remain the same. Now, we will start from the crew lobby during the last session that I will take, tomorrow. And in case you have any questions, then you may please ask, or we will break for lunch and we will continue the sessions tomorrow. Today, I have fixed two face-to-face interactive session with you. Have you received the message? You can unmute, any one of you can unmute and, say, have you received, good afternoon. Have you received the message that I have a session with you today evening? No. afternoon. Good afternoon. Have you received?
Yes, sir. Yes, received, sir.
Okay, fine. The 3A received. What about 3B? 3B, have you received? There is no response from any participant from 3B.
Yes, sir, we have received.
Okay. So, any one of you who would like to have some interaction, you are welcome to come for that session in your nominated room. Nominated rooms are room number 4 and room number 5 respectively. I'll be available from 4:30 to 6 in Manthan today, and the attendance is not compulsory. In case you want to remain present, or if you want to ask any question related to electrical engineering or anything which is not related to electrical engineering, which I can answer, then you are welcome to come. Okay, so the attendance is optional. We will follow all social distancing norms. You please use your mask when you come for this session. There is a question. Can you please tell about question paper pattern and important topic that I will explain it to you in tomorrow's session. I have already decided the pattern, and the topics are again almost everything is important, but still I will try to give you some hint when we meet tomorrow in the last session. It is not going to be very complicated question. You have to be a little bit alert when you attempt the question. That is all that I am going to say now.
Data we have to remember, sir, regarding the examination point of view. Since number of data is there, the transformer capacity like this, how much voltage required, step down, step up.
Some very basic data will be required, but not detail like the size of the contact wire, what is the current carrying capacity. My question paper will not be more on on data. It will be more inclined towards the concepts that I am going to teach you. Okay, so
Yes.
but some basic concepts should be known. Like for example, if I say the DC sets which are provided in the power car, what is the voltage that it is generating? So 750 volt.
Yes, sir.
So that is something very simple which you should remember. Or the say for example the frequency, whether it operates at 25 hertz or the 50 hertz. So some basic data will be required to remember, but you don't have to remember the most of the diagrams I am showing you in the slides, because I am resisting my temptation to ask you to draw in the examination. So just understand them. I may ask some questions which are related to the diagram, but per se I will not ask you to draw the diagram. So you need not bring a pencil with you when you come for the exam. That is the something important. And most of the data, like which I have told, like what is the frequency of IA schedule, IB schedule, IC schedule, that you don't have to remember. I will not be asking you to remember what. I will not ask what is the periodicity of IB schedule for, say for example, W87. So you don't have to remember that table. But how do we use some of the terminologies? That what is the encumbrance? What is a mast? What is how we nominate the locomotive? What is a bogie? What is the AC loco? What is DC loco? Those are simple concepts that you should. Okay. So you don't have to go into much of the remember part of it, mugging part of it, but try to understand the concepts. And anyway, later on tomorrow we will discuss on this issue again. Before we end the session tomorrow, we will have a discussion on this topic again. Okay. If you have anything, thank you very much. Take care. Right.
Thank you, sir.
Thank you, sir.
Bye bye.
Thank you, sir.
Thank you for a